theme that we've gone with tonight is data-driven, and I have to say it was inspired by our next presenter, Genevieve, who is going to be presenting next. And I think I've known Genevieve since about 2010, when we were both teaching in schools in different parts of the country. And Genevieve has been sharing lots and lots of examples of her projects online, and it was through seeing a lot of these, I thought, my goodness, why have we never had Genevieve come to present at one of our jams before? Genevieve, are you going to unmute and join? Yeah, okay, your camera's coming on now. Okay, I started to worry just for a little moment then. Okay.
No, it's just the internet was a bit slow. Probably my boys are gaming. Okay. Hogging the bandwidth.
And we will be going into the breakout rooms, or which we call the jam jar, in a little while. And Genevieve, we're going to give you your own breakout room. So you're going to.
Oh, I want to go to the other ones.
Well, you can always move about. You're going to be in room 4. I've just had, oh, hang on, beep, 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 beep. I've just had information from Gary that unfortunately he's not going to be able to join us in the breakout room. So it's going to be Dr. Footleg and Malcolm together in the same one. Right, my camera's going off. Genevieve, you start. Okay, cool. You're ready?
Hi everyone, and Alan, thank you for inviting us. This is actually cool. And it's quite interesting to watch the other talks, because each one of them actually plays a role in my current project, which is quite fascinating. But yeah, so I am Genevieve Smith-Nunes, and as you know, I'm an educator. So I was traditionally trained as a maths and business studies teacher, ended up doing computing because that's like the cool stuff. It was called IT when I did it. And this is a wonderful sort of illustration that a great artist, Annalise Lim, did about me as a human. So these are all the things that make up me. So I use a lot of external data sets for my ballet productions, which actually are the R&D platform for educational resources. So with the weather one, that was our second ballet called Data Storm. So linking into the little weather box that you were talking about earlier. So we used the weather data, which I'll chat about later, but as actually the mapping and the wind as the choreographical patterns and things like that. So yeah. And the little bit at the bottom, the electronically enhanced, is actually, I have an implant in my spine for chronic pain called a high frequency spinal cord stimulator. So I get to call myself a cyborg. Unfortunately, it doesn't work very well at the moment. So a little bit of a broken one. But yeah, so I'm currently a lecturer at Roehampton in the sort of School of Education and also in digital media. And I'm doing my PhD in creative computer science with my classical ballet at Cambridge. So I've just moved to Cambridge last October. So I get to do my own work for fun all the time. It's so cool. So a PhD is pretty hard. So, but yeah, so one of the reasons why I started it was there was girls in my class, but they would never go further. They would, they might take it at GCSE. We had like 1 or 2 initially. And then at the time when I was teaching A-level, they'd go up to like AS, but they'd never go further. And it was just, because I come from dancing school when I was little, and obviously programming, Dragon 32, breaking apart your Bon Tempi just to see how stuff works, because you've got an older brother. So for me, code was just a natural part of how I kind of grew up. And with going to dancing school, I just saw ballet as the equivalent of a programming language. So classical ballet is incredibly rigid. So it has rules, steps, and kind of motifs and functions exactly the same way as you might get in Python. So it's actually quite interesting to look at the synergies between the two. And so these are the projects I've done so far. And there's actually another 2 that are on there because they're not fully finished just yet. So Erasure was the first ballet, and we brought that out in 2014 to align with the new program of study that was coming. So here you can see the dancers. So behind you have an inverted binary tree structure, which is actually using Connect data. So it uses skeleton tracking data eventually to create another human virtual dancer. And then we have our dancers here. We're actually in this particular bit of the ballet, which I'll show you later, is they're doing a bubble sort with checking and validating. So the Hungarian bubble sort dancers, but a little bit kind of prettier. So yeah, we also did binary counting and Boolean. So the image at the back with the blue lights were actually, you can't quite see there, but they were actually circles and crossovers of data where the connect data crossed over, and these little ones and zeros just here. And then they did binary counting with torches. So they danced in pitch black, minus just the screen and the lights on their headdress and their dresses. So that was pretty cool. Though when they did the actual proper performance, they inverted all of the counting, which was kind of cool, but that was good, it was great. So and what we use is we built a Connect server, so it just uses like a Connect 360, or it just uses a Xbox One Connect. We also got it to use it with the Sense camera, the Intel one, so it just creates captures or schleps, as we call it. That's what our file's called. Schleps are all of your skeleton data and just outputs it into a JSON format, and that's actually available on our GitHub, and I'll actually post all of the links to that. And just to link in with the thing, I'm just going to send you the link of our Hydra's teeth. We have lots of JSON data that we capture, but obviously we can't actually share a lot of our data because the dancers that we use are under 18. So all of the data that we do share is anyone that's over 18 and actually agrees to share that. So you have to kind of make sure that everyone involved wants to and is willing to share it. So the next piece was actually this bit where we did this whole virtual dancer. So again, it took a binary tree structure with the skeleton data. And interestingly, because we've been through lots of rehearsals, both myself, the choreographer, and the developer we worked with could actually tell which dancer it is, and we still can. So that's kind of cool that you've got this natural kind of gait or dance position or movement that is individual to you. So that's quite fascinating, but also quite scary in terms of a data ethics point of view. So again, this is eventually that whole piece turns into this. There is no music I'm showing you here because we actually used we paid for a public license to do the live performance, but it doesn't count for streaming. So if you heard on this, it would actually cut the actual feed off on YouTube. So that's why it's one of the things that we're looking at is actually creating our own music using the skeleton data and brainwave data, which I'll get to later. So I'm quite fascinated with that MIDI Python one, because that's what we were looking at, using something similar to that, and somebody else has built it. This is so cool. So I love that. I love the idea that, you know, the community's there. I think somebody else was chatting about that, the idea that, you know, people on Twitter and wherever can actually help you and share information. So it's great. So just to give you an example, so this is our prototype shoe, and I still have it here. Like everything, it's covered in duct tape, of course. Why wouldn't it be? So we use off-the-shelf boards, but as you can see, they're pretty large. And when it comes to actually a dancer's point of view, it's actually quite a difficult thing to dance with. So there's a health and safety risk when you're using like hardware with dancers. So the point shoes normally go down on each other, so we have to be very careful with that. We need to have individually addressable LEDs as well because of the data that we're coming in. So we have like either the weather data for one of the other ballets, or we were representing pain data based on the movement of the dancers. And the next one's going to be sort of data latency and signal processing through the brainwave data. So it's at the bottom is what looks like a little kind of bit of plastic is actually Velostat. So it creates like a pressure sensitive switch, and it's actually thin. It's like, it looks like a black bin bag, if I'm being honest. And we just used thread to create this switch. And when they went up on point and the pressure going down actually triggered the lights to fire. So that was actually quite cool. Again, it's quite tricky working with any kind of performance-based costume. So these are incredibly hard to stitch into. The floaty fabrics cause lots of kind of problems with the sort of static and also the kind of flow that you want and the safety elements of stuff. So you have to kind of think carefully about how you would address those challenges. They're kind of fun though. So one of the things that we're looking at is actually building our own little PCB. So it's much smaller on the point shoe. Point shoes are rock hard. So it's okay to kind of like just duct tape it onto the front. I'm quite happy with duct tape, even in a live performance. So, and then this is just one of the ballets that I want to show, which is, it may be a little bit dark and a little bit jittery because of the internet, but this is where the dancers are doing a bubble sort with checking and validating. So they go through in height order. It's very difficult to tell the difference in height from this video, but that's what they're actually doing. And then eventually, following this little section, they went into an insertion sort using this. So this is the same way that the Hungarian dancers do with their numbers, but we've done the extra layer of checking and validating. So they do a curtsy and then they do their arms up. Again, these are all very structured routines within the sort of ballet programming language, if you want to call it that. So that's why it was actually quite interesting. And then it's quite a long piece, this one, so we won't show all of it. But at the back, the inverted binary tree structure actually converts into the human dancer that you saw previously. So the lights on the dancers that you can see is quite jittery. And then this is where they're moving into the insertion sorts. So it's actually quite cool. So I'm going to just move on to the next one where we're actually using weather data. So at the back, we have a heat map. So this was live in the performance. So we have a live weather data at the time of where we were in Brighton, based on a heat map, but with the tones of blue to go with this idea, the theme of weather that we were looking at. Here we also have projection mapping. So we use like free open source software to do projection mapping. And then I gave a couple of workshops at the RI, and which was really cool because it was pitched as a sort of more of a creative arts approach, even though it's highly technical and really exciting. But it's they said that they got more girls at that workshop than they would have done necessarily. So that was quite interesting. So the dancers here are representing parallel and serial data streams. And they have little lights, which you probably can't see on their dresses, that kind of are cycling up and down, and they're an 8-bit data array. So we did things that wouldn't cost a lot. So like just 8 lights so that you can work with, packets of data. So they're also representing packets of data. And the dancer with the light up cube is the 1 bit that we've followed all the way through on her journey from one side of the world to the other, using like weather data and protocols, viruses and compression algorithms that we kind of reconverted into dance patterns and data visualizations. So the ballet that we did after that is Pain Bright. It was kind of more of a personal one to look at pain signals and how chronic pain is dealt with in the body, and actually also looking at how people's perceptions of technology enhanced humans is more like Rise of the Machines Terminator, when actually there's lots of people like me that have devices that are medical based, and actually quite, some people are life-saving devices that are similar to mine, but obviously mine's to deal with the chronic pain that I deal with. So I've had, I think 32 spinal procedures and 7 full spinal surgeries. This is the 2nd implant I've had. And I have like electrodes in the spine, and this is an artist's representation of actually an image of my implant. So I have the device here. So this is like the microcontroller, very expensive one, by the way. It's a medical one, so it's not quite an Arduino inside, but it works functionally in the same way. Then you have these connectors, and then up here you have the electrodes. So I have like 16 electrodes trying to disrupt the pain signals going to the brain. So fascinating how the brain and the pain gateway works and the sort of pain pathway system. So we took this idea of the pain gate theory and the pain pathway and represented that in different dance forms, and then also in terms of actually looking at the dancers. I did try EL wire. It doesn't actually show up on a dance stage, it's not bright enough. And it also creates a high-pitched sound. And when you've got dancers who are younger, they can really hear the high-pitched sound that you get with the sort of battery packs and stuff. So we actually just used neopixels and like strips of them. So they had really floaty dresses, and I used hemming tape, you know, like iron-on hemming tape, to lock in the actual lights into the fabric. And actually that really flowed really well. And obviously from a safety point of view, we had to do low power because the dancers are obviously, you know, constantly moving, and you need to be very, very conscious of the safety of your dancers. So one of the other things that we did with it is that we wanted to I wanted to bring some new technology. So every time we do a new ballet, we bring something new so that we can actually teach it in the classroom. One of the things that we did here was VR storytelling. And we particularly used the Daydream because of the accessibility nature of it. It didn't really need you to hold anything. It was very soft on your head. I'm very conscious of accessibility and access to all people. I work with another project dealing in a social prescribing. So lots of patients are, you know, have different challenges and difficulties. So having something that's quite soft and easy to put on and not going to disturb, something like a wig or whatever, was quite important. And yeah, so it was just a story that took you with it. And we made sure that it didn't have that kind of VR sickness as well. So we actually looked at it quite a lot. Like I only looked at a video. I didn't really look at it in VR until like only 3 times before the final version, so that I could still understand what it felt like. So that was quite cool. And then I converted that into classroom resources using CoSpaces, but I'm now going to look at converting it again, like similar stuff into another platform, because that's actually doesn't even have a free, has a limited free platform, whereas we need to look at platforms like Blender or Unity or whatever that actually are more open to that. So that's the kind of that one. And this, sorry. So we looked at some of the sort of animations that we could do to represent kind of pain signals and the brain firing. And this is something that we're possibly looking at again for how we deal with the brain signals that we're doing for the next ballet. This is some of the software that we have used. So open source VR is really cool. Unity and Blender, Make Human to create the actual models. And these are all the platforms that we use are free or open source. So the next one that I'm looking at, the current ballet, which actually works into my PhD, is looking at data transmission, signal processing, and cognitive privacy, or neuroethics, which is part of data ethics. So because the EEG headset, which looks like this, which I'm using an emotive one. So these are non-medical grade, but you can get medical grade ones. And then it's out, obviously it records your brain. It gives you lots of stuff like this. This is on the app just to show you what you can just play. You can either get the full raw EEG and then it outputs into a very specific format that you can push through into Python and whatever. There's some amazing tutorials, and I'll give you the link in a minute. And then I just want to show you what it looks like and why this is super important. So the brain transmits signals, so it's constant using signal processing and data transmission. So we can teach those things by using hidden data. And what are the ethical implications of using hidden data? We kind of need to focus more on students understanding the kind of their own data privacy. And this is like a really fun way to do it, because actually seeing your own brain is kind of cool. But obviously, like seeing your own brain and then you're sitting with 20 neuroscientists might not be as cool. but the idea that you can and it just outputs to a CSV file. So how cool is that? So we're going to be sharing the data of myself and also the developer, and then the choreographer has also agreed. But obviously we will have aggregated anonymized data sets from the whole project. And then this is what it looks like when you want it to use the facial recognition, the muscles as well, so you can get it to control. And what we did was we took a set of simulated data and built a Scratch extension for it that worked with this this particular part of the Mind Your OSCs. And so it uses open sound control in order to capture the data from the headset to the thing. And this is what the Scratch element looks like. We haven't actually, so when we did this was 2 years ago. We've still got it on our own devices, but we haven't pushed it to Scratch just yet. So somebody's asking about the brainwaves. So I have a specialized set. This is the only thing about this project. You do need an EEG headset to do this, and I use the Emotive one. This is a 5-channel headset that picks up your brainwave data at different wavelengths, and it's if I just go back, so it picks these up as like a number, similar to kind of the like what we were talking about earlier in the sort of MIDI one. It just takes the different gamma and delta and all of the different wave formats, and you have the raw data, which looks really messy as a sort of running graph. And then you can, so there's a really good series of talks on what's called BCI, Brain Computer Interface, by the guys from Neurotech X. And one of the videos in there is a guy doing a tutorial with Python, and it's fascinating. Really, really, really is interesting. And they're super nice as well. So they're really nice community, even if you're like really new. So they're like really helpful in terms of that. So that's quite a one. You can actually build your own EEG set. There is like an open source set, but it's actually the same price as this one. And obviously we will be dancing with this on the stage, whereas the open ones have lots of kind of large raw boards, you know, like raw boards like this with angles on them. So from a safety point of view, that's why we went with this one as opposed to what would have been cool to build our own, obviously. And there's a few other ones as well. If you look at all of the talks, there's some other people doing really small, simple headsets. No, yeah, so some of the headsets are like, wow. They are pretty expensive. But yeah, so that's kind of where I am at the moment. So I hope you enjoyed my crazy ballet talk.
This is Genevieve. I don't know if you've seen how much has been going on in the chat.
No, I didn't. I only picked up a few bits.
Really stoked it up a lot. There's a lot of people going like, oh my gosh, if we take Gary's robot and combine.
Yes, exactly. And every single one of them just fed beautifully into it. I couldn't have picked a better like, you know, flow of people talking. It was amazing.
Which is brilliant. It's exactly the desired effect, because when I've seen a lot of things, because you have an Instagram account you share things on, you share things on Twitter. When I see them, I've thought for so long, we need to get Genevieve to come along, because when people see what you can do with all of these, I mean, there's a lot, isn't at the moment?
Yes.
Fitness products and integrating, you know, your fitness regime in with apps and tracking it and all this, but people don't consider that with dance. Now, one of the things I'm wondering about is the current lockdown kind of scenario.
Yes.
Forcing you to think in different ways and innovate and maybe finding ways of connecting people that can't share the same breathing space.
Yeah, so one of the things that obviously, you know, I still have to do my PhD, so I have to flip it. So what we're looking at is can processing with something like Big Blue Button or Zoom, and it is possible. It might not be amazing, but that's what we want. So we're building a kind of new Connect server, and then pushing that data into something like into Unity and Blender and things like that to build particular other objects that we might do. So the other thing for people to do would be Aero, which is Adobe Aero. It's a free app, and it's an AR app, so that's kind of cool. So we're going to be doing AR with ours. So I know that you can push to HoloLens with the brainwave data. It's something that we're looking at, but the whole thing will be. Currently, I have 2 running protocols, obviously. One, if we can, you know, unlock down, and then one where we currently are, which is fully virtual, and including the ballet, which will be fully virtual. So we're going to be recording some of the dancers with like blue screen and stuff as well. So that's going to be great, because you can actually do some of that with with the platforms that we have, and you can do post-processing on the actual videos and things. So it'll be interesting, to say the least.
The other thing I was wondering about, when I've seen groups who perform, so for example, if I say something like diversity, a lot of people have seen them, and a lot of their routine is obviously it's rehearsed to death, where, you know, split-second precision and time for every all to be lined up and doing things.
Mm-hmm.
Does this technology offer potential for people to assess their own performance and see how well?
So Connect and everything actually has actually been used a lot in dance, and it's usually for injury prevention. So if you imagine being on point is actually quite a dangerous activity, and it is. But it's quite interesting in terms of that, how it's being used. But we want to use it more for the creative side of it. So my whole kind of thing is that this is just another way that you might want to have a go at teaching computing, because actually ballet, opposed to say other forms of dance, doesn't have the same alignment to a computer programming language. So for example, lots of, like, you know, Argentine tango has steps but no rules. So there's like things like that. So you can't. So for me, it has to have that kind of clarity. You know, it has to have its own syntax or lexicon or whatever. You know, ballet grammar. And, you know, there's certain ways that your body has to move depending on what your feet are doing. So there's a combination of elements that only work and are correct. The same way as you might write a function has to be in a certain order. You have to use the specialized words. So that's where the alignment comes. And I suppose for me, it seems very normal, but I have to bring other people on my journey.
Okay, so you're going to try and get me into a pair of ballet shoes, is basically.
Yeah, well, ballet. Yeah, so ballet has rules, Dave. So I'm not being a rebel. I'm actually keeping to my boundaried rules. That's the whole point. And actually, yeah, go ahead.
Oh no, sorry. I was just going to say, well, thank you very much. You've been on point tonight. Now, the next bit